Okay, welcome back to the part 4, which is actually, I think, the 8th video segment. And we just finished talking about designing a light plane, and now we're going to build one. So let's get right to it. Okay, let's build a frame for a light panel, for a light plane of the aperture diffuser type. These should always be assembled on a flat surface. That means a surface without very many variations. So it needs to be relatively flat, not warped or twisted. This is the tile floor of my covered porch in the Dominican Republic. I also take advantage of the tile seams as straight edges to monitor the squareness of the corners. Be sure to pick straight, untwisted, unwarped boards for this project. No snakes. The corners are glued and clamped, immediately drilling pilot holes and running in screws. Minimum of 3/4 of an inch penetration into the end of the receiving board. If you take a close look at these corners, you can see that they're overlapped. You do not want to waste time in mitering these corners. Anytime you miter corners, you're taking a chance of having the miter open on one end or the other. And then when you tighten the screws down and glue it, you're actually putting pressure to distort the squareness of your frame. These butt connections, butt joints, work absolutely perfect. You can't see them anyway, and they're much easier to work with. Also, if you assemble these on a flat surface like I have here, you could also compensate some for twisted boards when you screw the corners together. Typically what people do is they will hold the two ends together as they're shown here, glue them and screw them, but they will do it with the board that's butting into the other one flush with the end of the board. Now if that board is twisted, then the other end is going to have a twist, but still they'll go ahead and keep assembling it all the way around till they have all 4 corners done. And if this board was twisted when you did the flush mount on the other end, you now have transferred the twist of the board into the entire frame. If you do it on a flat surface like this, you can kind of monitor that, and you can allow for a little unevenness in each corner, because the goal is a square, straight, flat frame. If the ends don't match up exactly flush, it doesn't matter. It's the squareness and the flatness of the frame that matters the most. If your outside dimensions are 24 by 72, then you're going to need to end up with a frame that's 24 by 72. If you're going to overlap your joints, as I did, then your frame components are going to be the dimension of one side minus the width of the other piece on the corner. For a 1x material, 24 inches minus 3/4 of an inch is 23 1/4. And for the 72-inch side would be 72 minus 3/4 of an inch, which is 71 1/4 respectively. So what I did was I cut 2 boards to 23 1/4 and then 2 to 71 1/4. That way when they're butted together, you end up with 72 by 24. Now if you do not have corner clamps, which I did not have in the Dominican Republic, you can follow one of these next procedures instead. Mark the ends of the boards where the screws will be driven, as you see here. Drill pilot holes, 2 in each corner overlap, but do not put the screws in yet. Now hold the corner together while keeping both boards flat on the surface, and then slide the drill bit back in while holding the corner even and square and tight, and drill at least 1/4 to 3/8 starter hole in the end of the receiving board. This will ensure that the tip of the screw will not walk away from the position as you drive it in. This is caused by the variations of soft to hard grain in the boards. It's unavoidable. Or you can skip the second use of the drill bit. In other words, just drill the pilot holes, pre-insert the screws as shown here into the pilot holes, drive them in until at least 1/8 inch of sharp point protrudes out the other side of the hole. What this does is it allows you to press the point into the other board when aligning the two. In other words, you line them up, get them nice and even, then you just kind of press them together, and those sharp points pierce the receiving board. That kind of holds it in place. Okay, so before you actually do that, though, apply the construction adhesive, then align the overlaps even and flat to the surface while pressing the sharp points into the other board, and then drive the screws in until the head of the screw is flush or slightly recessed. Don't go too far. If you drive it in too far, you may split the board, and it may split either board or both. If you do split the board, quick pull the screw back out, pull the glued surfaces apart, wipe them off, force glue into the split, clamp it, and leave it for several hours minimum to allow the glue to bond, and then try it again. Only this time be more careful. When the corners are, or I should say, when corner clamps are available, they are a real time saver. And they work towards keeping the frame flat during construction. For narrow boards, one clamp per corner is sufficient. So you see here I have 1x3s, so I'm only using one screw and one clamp. And basically, the clamp is to hold the boards in position while I drill the pilot hole all the way through the board face you see here where the screw is, and on into the receiving board. And while it's still clamped and glued, then I run the screw in. That way it holds its position during that whole glue and screw process. So once again, you would take your two boards, put them in the clamps. The one that slides up against the other one, you want to put that one in last. So the other one that sticks out all the way, you put that in the clamp first, clamp it down tight, then slide the other one in tight against it, clamp it down, then loosen up the other one, the first one, and move it back until the cut end is flush with the side of the other board, and then tighten the clamp back down. So I'll say that one more time. The clamp on the right gets clamped down with that board first. Then the other board on the left gets slid in so it's a nice tight fit, and then you tighten the clamp down. Then you loosen up the clamp on the right, slide the board left or right until it's nice and flush on the end, keeping the boards flat on the surface this whole time. And then run the right hand clamp back down tight again. Then loosen up the left clamp. Slide the board back, put glue on the surface, slide it forward tight, and clamp the left clamp down. Then drill a hole on that marked line so it goes in at least 3/8 of an inch into the receiving board. Pull the drill back out, insert the screw, and drive the screw in. Once the screw is driven in flush or a little recessed, you could remove the clamp. Now, if you have lots of clamps, leave them on for as long as possible. Otherwise, once the screw's in and good and tight, just take the clamp on and move to the next corner. Make sure you didn't skip any of the instructions here. Cut lengths, mark one end of each board with pilot holes. Drill pilot holes, slightly smaller than the screw diameter. Install screws, point just visible. Of course, you have to apply some glue there. Okay, if you're working with wider boards, in other words, a deeper white hole, a deeper light mixing frame, then you want to use two corner clamps, one on the top and one on the bottom. But the procedure is exactly the same. The board to the right, that one gets put in first, and then both clamps down tight. Then the board on the left gets slid in against it tight, and those clamps on the left tighten down. Then you loosen up the clamps on the right, slide the board left or right so it's a nice flush fit with the other board, the board on the left. Then you tighten the clamps on the right up again, and this is what you have right here. Now you can see that it's not an absolute perfect fit. If you look at the joint there, if you go down towards the bottom, you see a little surface showing. That means that that board is slightly warped. Not to worry. Make sure you keep it flat on your surface. That's what you see here. I'm doing it on a tabletop. Now, Once you've got them all lined up correctly, then take, and you notice I didn't mark where my drill pilot holes are going to go. That's because typically when I'm doing this myself, I just eyeball it and it always works out. But at this point, you would take and drill 2 or 3 holes, because that's a long, broad board, 3/8 of an inch from the end of the board, and you would drill the holes through the first board and into the end of the second one at least 3/8 of an inch. Pull the drill bit back out. Now, you would loosen the clamps, both clamps on the left. You would loosen those, slide the board on the left back, giving you enough room to reach in there and put glue on the edge of that board. Then you would slide it back in tight, tighten those 2 clamps on the left back down, and now you would take and run the screws in those 3 holes. Now you notice I'm doing this on a kitchen table. This is in our kitchen back here in the States. Your wife has to really love you a lot to allow you to do this, to put up with this kind of nonsense in her space. You scratch something, get glue on something, and you're dead meat, my friend. Okay, here we are back in the Dominican Republic. Now, I threw those slides in there with the clamps simply because I mentioned them. I didn't have any clamps when I was in the Dominican Republic, and it all came out fine without the clamps. But I mentioned them, so I threw them in there so we don't have to cover it later. Here we are back in the DR, and here I can glue and paint there without any concern or repercussions. Everything is ceramic tile, paint cleans off of it easy. And I don't have any fine furniture. Now, I might not have mentioned it, but I am building these for the mission there run by some good friends. And this is my apartment there. I hang out there as much as I can. Okay, so you built the frame, 2x6, 24 by 72 inches. Now, cut the surface diffuser to the outside dimensions of the frame, the light blending spacer, the frame, and then paint it matte white, and you keep adding coats until it's really white. Depending on what kind of paint you use, you might have to wait a half hour, 45 minutes in between coats. If you don't, it may gall the point and kind of booger up on you. But you know what's not going to hurt. Nobody's going to see this surface. Remember, this is a diffuser surface. Now, this was very inexpensive masonite. Masonite is the brand name for that dark brown press board, like pegboard. Pegboard is masonite with holes in it. Everyone doesn't call it masonite anymore, but, you know, that's what it was always called when I was growing up. The name stuck. Now, you can see it's not perfectly flat. You can see a little warp in it. Even the moisture of the paint caused it to curl a little bit. I got away with using this inexpensive board because I was very careful handling it. I didn't drop it, so it didn't get broken or cracked. Now, I painted on the rough side thinking I would get better diffusion. However, if you're thinking about using double-sided tape, then paint the smooth side and make sure that the paint is well cured before you apply the strips. If you do use the tape, you might want to tie wrap it in a few places for a little insurance. We used tie wraps. I did not use a double-sided tape because in that humidity down there, I knew the tape wasn't going to stick. So here's our surface diffuser. Really, a very inexpensive piece of press board, masonite, painted flat white. And you can see the frame standing up there in the background. I don't know if I mentioned that, probably didn't, but you need to paint the inside of that frame white because that's part of the diffusing surface. Okay, let's mark and drill. But before we do that, just want to reiterate about if you're going to use that double-sided tape to mount your strips, you should probably paint the smooth side of this panel instead of the rough side like I did to get better adhesion. Otherwise, we'll just mark the drill holes for the tie wrap. Here we're marking the holes. First, you take widthwise and you put marks for the center lines where you're going to mount the strips. It's always nice to have a straight board or piece of trim laying around to use for a straight edge, like this one that was left over from another project. So you're probably looking in there, well, that's a strange looking piece of wood, a strange board, but it was something that I routed to add to the edge of a shelf to decorate it. But anyway, works good as a straight edge. You put marks at your strip spacing on both ends of the back panel, the surface diffuser, and then you use the straight edge and draw a straight line the full length. Now you see we've already gone ahead here and then went back and took a photo of someone holding a pencil where that line gets drawn from the straight edge. So actually we've already done all this and marked the spacing for hold downs and started to drill some holes. At this point I have acquired a very lovely young lady to be my assistant, the wife of the gentleman down there that started the mission. So I kind of pooped out here and I'm just sitting down having a cold pop and watching her do the work. Now we're going to mark the intervals for the tie downs. And you need to be careful when you're doing this. So at this point you probably should have taken your LED strip. You've determined the distance between the strips and then laid them out to determine where you want the tie downs, because you don't want the tie wraps going across the top of the LED and blocking the light from the LED. That might cause a little dark spot in your plane. Typically, I put the tie downs where the OK to cut here marks are. In other words, where the little copper trace is showing it's got the scissors symbol. I tend to run my tie wraps across those points. By the way, my helper, not just another pretty face and smart, but she has a passion for power tools and all those cool things. Okay, once you've got all your tie down intervals marked, then use some scrap wood to give you a drill gap, and then move the rows over that space and drill those holes one hole at a time, or one row at a time. And here we have our back plate all drilled and ready to accept LED strips. As you can see, this is waterproof LED strip. And I show two tie wraps before they're actually pulled tight. You see the marks there I was talking about where you see the copper traces and it says 12V, BRG. You see a little pair of scissors on a black line. That's really where you want the tie wraps to grab. Now if they grab anywhere in between the LED devices, that's fine. But I typically put them right at those marks. Now remember that these strips are metric, so you may think it's 2 inches, it's not. So you want to be careful when you're making your marks, because when you get down the other end, you're going to find they're going to be off. Well, after you've drilled out all of your holes, then you start at one end and snug that end down, thus allowing you to hold the strip taut as you tie the strip down progressively from one end to the other. So you start at one end, tie wrap that end down, pull it really tight, and then pull the strip snug as you go so it's laying nice and flat. Now one problem we ran into is these did have the double-sided tape on the back, and the protective paper, you know, that covers up the sticky surface but doesn't really stick to it, that tended to buckle and keep the LED strip up off the back surface. So you need to cut that here and there so it overlaps so it doesn't buckle. Okay, here we have one strip down and 3 to go. When I say one strip, I mean one 5-meter strip cut into 3 pieces. Now, they're not 3 equal pieces. It doesn't work out. If you look at the gaps there, if you look close, you can see the little copper foil areas every couple LEDs as you go down that strip. So you can only cut it in those locations. Now, one thing I'm not going to show you right now, much later, in another segment, couple segments from now, I'll show you how to connect these up electrically. See, we cut them. So now we have to connect them back together. So here's what's going to happen. You can't see it, but down at the other end, remember this was all one strip, one 5-meter strip, 16 feet 5 inches. On one end, you have a connector with 4 pins on it. On the other end, you have a connector with 4 pins. I cut this at 2 places, which means down at the other end, 2 of those, the 2 on the outside, still have the connectors, and the one in the middle does not. So I am going to take and clean off the silicone coating on the middle strip there, attach a connector, and then I'll splice the 3 together. So all 3 of these will be controlled by the same LED driver. The fact that I have 3 strips electrically connected in parallel actually will improve their performance as opposed to connecting the 12 volts to one end and letting it run the full 5 meters. We'll explain that in another segment later. Okay, so here's one strip down, meaning one 5-meter strip cut into 3 lengths and almost completely tie wrapped down. It's still laying in there loose. You can see the tie wraps aren't snug yet. This is just one 5-meter strip, so obviously I used 2 5-meter strips. These are the RGB devices. In other words, each one of these is red, green, and blue. But these are not the 50/50 series. These are the 35/28, the ones that aren't quite as bright. But believe me, it turned out that 6 lengths, or 6 within a 2-foot width was way more than what we needed. Like I said, this was 1 5-meter LED strip divided into 3 shorter strips of almost equal length. One of them just slightly longer than the other. No problem. There's so much light bouncing around in there that you can't see any deficiency where the 2 shorter strips are. The second 5-meter strip was cut the same as lengths as this one and also tie wrapped to the surface diffuser. Now here's where things get a little dicey. I have to skip some steps here because I suffered a blow to my ego. I was walking up the steps with my hands full of things and my foot slipped out of my, I guess you would call them sandals that didn't have a heel strap. So it slipped out. I caught my big toe on the ceramic tile corner and ripped a gash down to the tendons. It took 9 stitches. So for a couple days, no, actually more than a couple days, they were calling me Franken-toe because I had these 9 big ugly black stitches all around my toe. What happened was that kind of threw me a curve, and although I went immediately back to work the same day on these, somehow taking pictures just slipped my mind. So here's what we're going to do here, folks. Pretend like this is the frame with the inside of it painted white and it's laying on a piece of black, or a piece of that vinyl drop cloth. It's actually laying on a piece of broadcloth right now because at this point I've already glued on the vinyl film and now I'm going to glue on the broadcloth. But let's pretend like I didn't glue on the vinyl. Okay, so pretend that this is laying down against the vinyl drop cloth. Basically what we're going to do then, using contact cement, we're going to apply some contact cement. We're going to apply some contact cement in a wide swatch right in the middle of each of the 4 sides, down towards the bottom. In other words, we'll take an area probably 4 by 4 inches and cover it with contact cement on the wood, right in the middle between the 2 ends, and then right below it on the vinyl. Now remember, this is broadcloth, but pretend it's vinyl. So I put contact cement on the vertical surface and on the horizontal surface right next to each other. Then I went across and did that on the other side, and then I did it on both ends. So right in the middle of all 4 sides, I have applied contact cement to the wood and to the vinyl drop cloth. You let the contact cement dry until it's shiny and it doesn't really stick to your finger. Then on one side, it doesn't matter where you start, you pick up the vinyl film. You don't pull it up real tight. You just kind of pull it up snug and place it against the wood, smooth it out, and it's stuck on there. Then you walk all the way around to the other side, exactly opposite. Now you pull it up snug, not tight, because you don't want to distort the sides. You don't want them to bow in. So you just pull it up until the film, and you can see the film right there in the middle of the table, until it looks snug, and then press it together and smooth it out. Now you have a tight or taut strip of vinyl film across the middle on between these 2 sides. Then now you go to the other 2 sides and you do the exact same thing. You take and pull it up, not real tight, but just so it's smoothed out, and then push it up against the wood, smooth it out, walk to the other end. This one you pull a little snugger and then press it in there. Now you've got a nice taut surface between the middles of both sides. Now that still leaves the corners, but you get the middle ones done first. Then you go to each corner, like you're looking at a corner right here in front of you. You would apply contact cement along the corner on both pieces of board and on the vinyl on both sides. Let it dry, and then when you go to pull it up, you're going to have to pull evenly out in both directions, and you're looking down inside the frame so you can see that you don't have any ripples. And then press it up there, smooth it out, and you should be good to go. Okay, that gets the vinyl aperture on there. We got this done, took it back upstairs, put it on the porch, laid it over the board that has the LEDs on it. And then we turned it on, and here's what we got in daylight. This is not in the dark. I mean, it's going towards late in the afternoon, so it's not real bright outside. And you can see the strips of LEDs. Now this is 2 strips, cut each into 3 lengths. So there's 2 separate LED groups here to control. I adjusted them both to the one that looks bluish, that's really cyan. So that is green and blue. So I turned up the green and blue on both strips and got it equaled out as cyan. And then the other one's just red. Now what you immediately probably want to say is, well, I can see the lines where the LED strips are. That's exactly right, because you don't have enough diffusion yet. You need a little bit more diffusion. The next step, and by the way, here's some more colors. There's red, green, and blue, and then cyan again. So you can actually see quite well, not just the lines, but you can see some little serrations where you've got something going on with each individual LED. But you wait, this gets better. Okay, now what we did is I took 3/4 by 3/4 strips, and I screwed them, not glued them, just screwed them down, because I might want to remove this later, replace the primary aperture, the vinyl one. I screwed these strips down all the way around the frame to space out for the secondary diffuser from the primary diffuser. But we're framing the secondary diffuser. This is 3/4 of an inch spacing. You got to have some separation. If you put the secondary one right on top of the primary, you're not going to get very good diffusion. You might use more space if you want. I tried 3/4 when I was experimenting. It looked good, so I went with that. That was easy to work with. A close look at the corners reveals the lack of need for a perfect joint. So if you look at the joint there, you'll see that there's a gap. So the boards didn't have to be cut perfect. I just cut them close, and in the end it's not going to matter once you glue the broadcloth on there. Now, this is the exact same photo we had before, only before we were cheating. We were gluing the vinyl on, not the broadcloth. This time we're going to do the broadcloth. Now, one thing I didn't do that I wished I had done. You see, on this side, the broadcloth is lined up about the width of the board. On the other side, the whole thing is still there. I should have cut the broadcloth for the size I wanted before I started, because it ended up being a pain on that other side with all that extra fabric there getting in the way when I was trying to, attach it to the frame. But it still worked out fine. So you do the exact same thing that you did before. You apply glue to both the fabric and the board, let it dry, and then push it up against, go on the other side, do the same thing, but after you pull it tight. Now this plastic lid here, I suggest when you're doing the broadcloth, because the glue will wick through the cloth, that you put down a piece of plastic underneath of it so it doesn't wick into the table or whatever your surface is. So we did this all the way around on all 4 sides. Then we did the corners. At that point we had the broadcloth glued directly to the frame. Now remember, you can glue the vinyl film to a separate frame and then screw it to the blending spacer, and then glue the broadcloth to its own frame as well, and then screw it on top of the vinyl frame. Okay, here's my assistant painting or trimming the edge of the box. She's very fastidious about making everything match. So she's basically painting the sides of the box a color that will make it blend into the background where this is going to be mounted at the church down there. Okay, now this is the result with the primary and the secondary diffusion. This is the piece de resistance, the coup de grace, the moment we are all waiting for with bated breath. The first one is a mystery until you see it, and seeing it is believing it. Believe me. Comparing it to the results of just a primary on the right, you can see it makes a big difference. Now you may think you still see something with two diffusers, but you don't. That's just an illusion. You can look and look and look at that, and I'm telling you, that is one even. Remember, this is a image capture with a camera and light that's varying in the room. And this is out on my porch. You have to keep in mind that there is other light sources here opposing, you know, the light coming out of the secondary diffuser. I'm telling you, this was perfect, even light all the way across this whole surface. Now this is 2 foot by 6 foot. You can make this 8 foot long, 12 foot long, 3 foot wide, 1 foot wide. You can make these any length you want, any width you want. Remember, there are some challenges when you go wider than 2 feet and longer than 8 feet, and they have to do with materials and support. There's the fruit of all your labors right there, folks. There's a primary diffuser. You can still see the line, secondary diffuser. If you look at the primary and shift to the secondary, at first you think you see some lines, but you really don't. That's called persistence of vision. You looked at the image on the right, and when you move to the left, it carried with it. And it takes a few seconds for the image to dissipate from the cones in the back of your eye. It's called persistence of vision. Okay, here's green. You see what a drastic improvement that is. Now you can see the fabric texture, but you won't see that 10 foot away. I mean, I'm standing right on top of it taking this photo. So there's red, there's green. You might, if you're interested in science, stare at the one on the right for 3 or 4 seconds, then quick pull your eyes over to the one on the left, and you will still see those bars of light, but they slowly fade away as the image dissipates from the cones in the back of your retina. Okay, here's blue, smooth blue. And there's the blue lines. The one on the right, primary diffuser only. One on the left, a secondary diffuser 3/4 of an inch out from the primary. That is an amazing difference. You wouldn't think that 3/4 of an inch and a piece of broadcloth would give you that wonderful result, but it does. Okay, here's the panel mounted on the wall at church on the platform. And you can see why she painted it that flat brown, because now it disappears into the wall. Now this is with a flash. You can see all kinds of things you would never see with the normal lighting in that room. Now you see the 2 controls? Each one of them has a red, green, and a blue potentiometer or adjustment. We're not going to go into all the electrical details on this time, but remember I used 2 5-meter strips, each one cut into 3 pieces. So that bottom controlled LED driver down there, controller, it controls the red, green, and blue of the devices on the lower half of the panel, and the other one controls the 3 strips on the upper half. So we can actually adjust it to get 2 different colors or all one color. Now from those controllers, matter of fact, coming off the top of the controllers, you can see a black, red, green, and blue wire. Those go inside the panel to the LED strips. Coming off the bottom side of those 3 knob controllers, a red and black wire, red for positive, black for negative, 12 volts DC. That 12 volts DC, if you follow the red and black wires down towards the bottom edge of the box, you will see a DC power jack adapter there that has the 2 wires screw terminaled into it, and it's tie wrapped down so it's strain relieved, and then that plug goes to a 12 volt DC 8 amp power adapter of the brick type, not the wall wart type, but the brick type. Now let's turn the light out and take a look at it. Well, standing this close, you can see the fabric, but you won't see it. If you were standing 10 feet out in front, you don't see the fabric at all. Plus, I noticed, it looks like this was adjusted, by the way, for cyan on the top and magenta on the bottom, which means that I've got all the blue turned on, and on the top half, I turned up some green to get cyan. On the bottom, I turned up some red to get magenta. You see the magenta that goes around the edge? That's not there when you look at it with your eye. The camera picked that up. So I don't know if it created it or it picked up something that my eye just didn't perceive. Either way, when you stand back and look at this, it was stunning, and it weighed way more illumination than what was needed. Now here's looking at the stage in the dark. Now never mind that other light plane off to the right. That's one that I built right after this one that uses just surface diffusion, and it actually takes one great big surface area painted white, and then there's strips that divide it up into 4 sections, and on the back side where you can't see them were a strip of red, a strip of blue, and a strip of green. So this is just kind of an experiment. I'm going to redo this one, but looking at the one we just did there on the left, that's adjusted to cyan, and when you look at that, it just looks like one flat, even light plane. So whether you like the color or not doesn't matter. You just need to see that it provided a ton of illumination, and that was not cranked all the way up. As it ended up, we had to turn it way down, even when the lights were on, because the camera, the video camera that records the events there, the sermons and lectures, it picked up a very strong level of light from that light plane. So remember, I mentioned that when we were talking about the dimensions and the design. If we turn the lights on, you can still see, and this is more light than would be on that aimed at this during a service or during an event. So you can see that that shows up nice and even end to end. Okay, that concludes construction of LED strips. We've continued and continued and continued and continued. In the next segment, which I'm not going to start for a while, so this is all you're going to see until I have time to work on the next presentation, you're going to see I'm going to build 3 more light planes for this church down there in the Dominican Republic, but they're going to be what I call the white hole, or the surface diffusion type. You don't have to fool around with any apertures, no fabric, no film. It's just LEDs, wood, and paint, basically, and some electrical components. Thank you very much for watching. I hope you enjoyed this.